Hello students. So this is a question from algorithm analysis and it is of 1 mark. And the question is, assume two positive functions f and g such that h of n equals to big O of g of n. And the question is 2 power f of n equals to big O of 2 power g of n. Okay. So what are the options? The options is whether this particular relation is true or not. The options are: it is always true, it is sometimes true, it is never true, and the last option is none of this. Okay. So let's take one of this function. Let's say f of n equals to 2n. Okay. So what is 2 power f of n? 2 power f of n is nothing but 2 power 2n, which is equals to 4 power n. And let's take gn equals to n. So 2 power, what is 2 power g of n? 2 power g of n is nothing but 2 power n. Okay. And according to this relationship, 2 power f of n is equals to big O of 2 power g of n. Okay. That means, what is 2 power f of n here? 2 power f of n is for as whatever we are assuming some function f of n and some function g of n. For those particular f of n and g of n, 2 power f of n is 4 power n and 2 power g of n is 2 power n. Okay. So now we have to prove this. So that means, according to the definition of the big O notation, there exists some constant c such that 4 power n is less than constant times 2 power n for some n naught greater or equal n. For some n greater or equal n naught. Sorry. Okay. Now let's think about this relation. Can we find a constant c such that 4 power n is less or equal to 2 power n? The answer is no. There does not exist any constant c. We cannot find any constant c such that 4 power n becomes always less or equal to 2 power n. That means this particular relation does not hold good. Okay. That means there might be some functions in which this particular relation will not hold good. That means this particular relation is true, not always, but sometimes. So the answer is option B, sometimes. Thank you.